Hey, and welcome to this presentation. Today I'll be introducing Educator's Friend. The focus is on a simple but important idea: how generative AI can support educators in creating learning content more efficiently without compromising quality. In this presentation, I'll walk you through how this approach works, what challenges it addresses, and what we can learn about using AI as a practical support in education. Welcome to Educator's Friend. The core question guiding this talk is simple but important. How can generative AI help educators design learning content more efficiently without sacrificing quality? That question matters because educators often spend a great deal of time creating teaching material, while generative AI promises support but also raises concerns about accuracy, reliability, and quality. In this presentation, we will follow one concrete study that explores this issue through an AI supported learning object, its design principles, and its evaluation from the student's perspective. The article starts from a practical problem in higher education. Academic staff face heavy workloads, and teaching content creation takes a large share of that work. Generative AI is then presented as a possible support for creating learning materials more efficiently, including quizzes, handouts, videos, and tailored content. However, the article also stresses important risks, especially factual errors, reliability problems, and bias, which means that AI generated content still requires careful quality control. The study focuses on information security education, where high quality and engaging teaching is especially important because students need to understand security concepts clearly and accurately. This leads to the article's research questions. Which initial design principles can be derived for using large language models to create learning objects? And to what extent evaluation supports the claim that such tools help educators create effective, also high quality, and engaging learning content? To understand the study, we first need to clarify what the authors mean by design principles and learning objects. Before presenting the artifact, the article clarifies two core terms. Design principles can be understood as practical rules for how to design something to achieve a goal. More formally, they are prescriptive statements that include information about the implementer, users, aims, context, mechanisms, and rationale. In this study, the authors present initial instance based design principles, not fully mature design principles. Learning objects are described as interactive web based tools that support the learning of specific concepts. They are focused on specific curriculum topics, reusable, and intended to promote learning. In this article, the learning object is a digital reusable module in an LMS about brute force attacks and password security. The learning object is grounded in computer supported collaborative learning, or CSCL. The article uses CSCL because it is considered effective for facilitating learning outcomes and because it builds on the idea that technology can support collaborative knowledge construction and problem solving. The authors draw on 7 CSCL affordances, including collaborative tasks, communication, sharing resources, productive processes, co construction, monitoring and regulation, and building groups and communities. This pedagogical foundation is implemented through four elements of the learning object: a text based motivational introduction, a learning video, quizzes, and collaborative tasks. These elements were guided and moderated by educators and displayed in visible sequential order within the LMS. The application domain was a bachelor level lecture on data privacy and information security at a German state university. To generate textual learning content, the study used ChatGPT Plus based on GPT-4 rather than GPT 3.5 because GPT-4 was considered more accurate, especially for German. At the time of the study, GPT-4 was trained only on data up to September 2021, so the authors added the WebChat GPT browser extension to incorporate more recent web information. For the video slides, Microsoft PowerPoint was used, including the AI based designer feature to generate visual slide layouts. For the voiceover, the study used 11 Labs because of its web based interface, human sounding multilingual voice, and German voice cloning capabilities. So, this slide describes the tools used in the study at that time, not necessarily a fixed recommendation for which tools educators should use today. The article then describes the concrete content created for the four pedagogical elements. ChatGPT generated the motivational introduction sheet, the voice-over script for the learning video, quizzes, and collaborative tasks. The learning video used a 391-word voiceover script, which was revised and then summarized by ChatGPT into bullet points for 7 PowerPoint slides. The final video was 2 minutes and 54 seconds long and used AI-generated voiceover from 11 labs. The learning object also included 24 quizzes across different formats and levels of difficulty. For collaborative work, the authors began with one existing mathematical task and used ChatGPT to generate 3 more complex tasks and explanations. The study also reports an intermediate indication about efficiency. Two educators from different fields estimated that creating a similar learning object without generative AI would take about 180 to 210 minutes. By contrast, the reported AI-supported approach took 130 minutes in total. This total includes both preparation of the language model and later adjustments to the generated content. The article treats this only as an initial indication of possible time savings, not as a controlled comparison or final proof that AI always makes content creation faster. Rigorous time comparisons are therefore left to future research, especially studies that compare multiple educators working with equivalent pedagogical designs. The first design principle follows from the content creation process. The article argues that educators should know the pedagogical concept before generating learning content with AI. This means knowing the planned learning elements, the expected content types, and the task constraints in advance. With that preparation, content can be generated coherently, one element after another, so that the learning object follows a clear pedagogical storyline. For ChatGPT specifically, the article recommends using prompt instructions for each element and keeping one session for one learning object. Without this preparation, AI may produce a large amount of content that is incoherent or does not fit the intended learning design, which would also increase revision work. The second design principle is that educators should use prompt engineering systematically when creating learning content with AI. In the article, prompt engineering is presented as a central mechanism for getting useful and effective AI-generated learning content. One important technique is priming, where educators provide validated reference material, such as documents or open educational resources, to improve accuracy and reduce hallucinations. Another technique is the use of personas, where the model is asked to adopt a suitable viewpoint and writing style, for example, an educator persona. The article also emphasizes self-reflection, precise prompts, feedback, and repeated prompting as ways to improve quality over several iterations. Together, these techniques are linked to the quality of the learning object and to students' learning and engagement. The third design principle is that educators should expect quality issues that follow from current limitations of large language models. In the study, the authors encountered false facts, missing information, and outdated content, even when they used careful prompting. The video script, for example, required 2 important manual corrections, and about 5% of its semantic structure was improved manually. The quizzes also needed checking. 2 out of 24 quiz questions were initially incorrect and had to be discarded. The point is that knowing these limitations helps educators revise AI-generated output more effectively and efficiently, instead of assuming that the generated material is automatically ready to use. To evaluate the design principles, the study focused on students' views of the implemented learning object. More specifically, the evaluation examined learning, engagement, and quality. The authors used a slightly adapted version of the LOESS questionnaire. The instrument included 12 quantitative items on a 5-point Likert scale and 8 qualitative items. with the qualitative questions tailored to the four pedagogical elements. The final sample consisted of 31 students after one invalid survey response was removed. Reliability was high for learning, with Cronbach's alpha at 0.906, acceptable for engagement at 0.793, and lower for quality at 0.624, which means the quality results were interpreted more cautiously together with the qualitative data. The quantitative results indicate an overall positive evaluation. All three constructs had mean values above 4.0. The median values were 4 out of 5 for learning and engagement, and 5 out of 5 for quality. All individual items had medians of at least 4 out of 5. The strongest items concerned practical clarity. Students found the instructions easy to follow, the learning object easy to use, and the material well organized. At the same time, two mean values were weaker than the others, helping students learn a new concept at 3.65 and being motivating at 3.90. The qualitative results add detail to the overall picture. The study received 212 qualitative feedback statements, which became 236 coded statements after splitting responses that referred to multiple subcategories. Overall, the feedback was strongly positive, more than 75%, and in some categories up to 88% were coded as like statements. Students described the video as helpful for learning, and some appreciated its metaphorical comparison, although others wanted more new information and more detail. The quizzes were also seen as useful because they supported repetition and offered different levels of difficulty, but some students found them too easy. Finally, students often describe the motivational introduction and the video as clear and well written. The video voiceover was generally understandable, although a few students criticized the voice quality or found it somewhat monotone. In the discussion and conclusion, the article answers the research questions by arguing that the AI supported learning object was overall perceived as effective, engaging, and high quality. The results also support the proposed design principles, especially the importance of prompt engineering and of creating content from a clear pedagogical structure rather than generating isolated materials without a learning design. Importantly, students did not report major coherence problems or fabricated content in the implemented learning object, which suggests that the revision process helped control some of the risks of AI generated material. At the same time, the article still warns that AI generated tasks and quizzes need careful human checking, especially for similarity, ambiguity, correctness, and wording problems. The design principles should therefore be seen as an initial starting point for further research, not as final or fully mature rules for AI supported learning object design. We have now reached the final slide of this presentation. I will now briefly summarize the lecture. The study begins from a practical problem. Educators face heavy teaching workloads, while generative AI creates both opportunities and uncertainty around accuracy, reliability, and quality. In response, the article develops a learning object grounded in computer supported collaborative learning, focused on brute force attacks and password security in an LMS. The workflow combines GPT-4 through ChatGPT Plus, web-supported prompting for more current information, PowerPoint Designer for visual slide support, and 11 Labs for German voiceover. From this process, the article proposes three initial design principles. Start from a clear pedagogical structure, use prompt engineering systematically, and revise AI-generated output with the limitations of current language models in mind. Finally, the student evaluation was overall positive for learning, engagement, and quality, but the article still emphasizes that AI-generated learning content requires careful human oversight. Overall, the study presents generative AI as a useful support for educational content creation, but not as a replacement for pedagogical judgment, subject knowledge, and quality control. That is,